So hello everyone, today we will be doing the biochemical test for carbohydrate. So for carbohydrate we generally use there are several tests, but we generally use three tests. These are Molisch test, Fehling test and the Benedict's test. But now the small problem arises how we are going to remember these three methods. So there is a small trick that is called it a code. uh, just remember your parents and your sister if you have. So there is a father, there is mother in our family, and there is sister, which in Hindi is called B. So the code found here is FMB or MFB, whatever you want to call it. So let's first take the M for Molisch test, F for Fehling's test, and B for Benedict's test. So now we have to just remember the result that will be obtained, the final result which confirms the this biochemical test. So in case of Molisch test, we get boilet ring formation as site of union of two different types of solution, and the Fehling's and Benedict's, they both get red PPT due to formation of cuprous oxide that we will be studying. So now there is a extract. What is extract? So let me first write the what extract actually is. So I have just write the what is extract. So extract is actually few grams of sample, solid sample, which we have to crush, then add few drops of water, making a paste. Then we will filter this paste using filter paper and funnel, and the filtrate that will be obtained, the liquid medium or material that will be obtained is our extract, which we will be using in the experiments. So let's talk about the experiment, the Molisch test. So when we have to talk about this test, there are certain subtopics, like what is the reagent used, the Molisch reagent. Then there is a procedure, how we are going to do this test. Then there is its chemical reaction and the principle. So the core thing that we have to understand are the reagent, the procedure, the chemical reaction, and the principle. So let's first talk about the reagent. So the Molisch reagent is actually alpha naphthol solution. That is, alpha naphthol is actually in solid condition in normal room temperature. So it has to be prepared in solution form with ethanol plus few drops of H2SO4 concentrated. This forms our Molisch reagent. Now the second thing, that is the procedure, how we are going to do this experiment. So for the procedure, what we have to do is, to a small amount of extract, we will add few drops of alpha naphthol solution, that is alpha naphthol plus ethanol, followed by 1 ml of concentrated H2SO4. There is no need of heat, and the chemical reactions taking place is also very simple. So let us take any pentose hexose sugar, cyclic sugar. So here is our cyclic sugar, oxygen will be there, CH2OH, and there will be OH, and OH. What will be happening here? There will be addition of alpha naphthol in ethanol and concentrated H2SO4. It will the concentrated H2SO4 actually not decomposition, it will dehydrate this hexose sugar and when it dehydrates, it then undergo condensation reaction with alpha naphthol. Alpha naphthol is actually a phenol with two rings, two benzene rings. So when it goes to that reaction, the condensation reaction, it will form a furfural. Furfural is actually furan with aldehyde group and CH2OH of this glucose. This is called furfural, and this furfural actually gives us our violet ring. And there should be one thing to be noted: the violet ring forms at site of union of two solution. So what will be the two solution? The two solution will be the alpha naphthol solution and the extract. Now the third thing that we have to do is the principle. From this reaction we can actually see that the hexose sugar or pentose sugar gets dehydrated when exposed to sulfuric acid concentrated form, and then undergoes condensation reaction with alpha naphthol, forming furfural, and this furfural gives us our violet ring. So that is the Molisch test. So now the second reaction, that is the Fehling's test. So we use the Fehling's reagent, and there are two types of Fehling's reagent A and Fehling's reagent V. In this reaction we will be using both of them. So what is difference is the blueness. The one is light blue, another is deep blue, but both have one thing in common, that is the copper. The copper present in a Fehling's reagent are in Cu2 plus state. Oxidation state is Cu2 plus, and it's actually a complex. Fehling's reagent is a very complex. So Cu2 plus, we can take an example of this oxidation state like CuOH twice. So this is also in Cu2 plus oxidation state. So now the second thing is the procedure. So in procedure we have few drops of extract with adding 2 ml of Fehling solution A and B, followed by boiling in water bath. So don't boil the test tube directly. We should be using the water bath. So what it will give, the end result will be formation of red PPT. So why red PPT forms is actually our main objective here. Now to understand the why red PPT is formed, we have to first understand what is reducing sugar. Reducing sugars are basically those sugars which acts as reducing agent, and they themselves undergo oxidation, and reduces the reagent. So what is happening here is let us take example of reducing sugar. like CHO, CHOH4, and the last thing CH2OH. This is our glucose, I think D-glucose, and this glucose, when reacted with copper hydroxide, CuOH twice, and यहाँ पर we can see the oxidation state of copper is actually Cu2 plus oxidation state. That is very important. So as I said, they reducing sugar reduces the reagent, so it will reduce the reagent and itself get oxidized. So when the glucose get oxidized, when we provide some heat, when it get oxidized, it will form this thing C double bond OH, sorry, C double bond OH, C double bond O, there is no H. So okay, one more thing here, we need an alkaline medium, because the Fehling's test and Benedict's test both are similar, only difference is the presence of alkaline medium. So we have to introduce an alkaline medium using NaOH. Now this Na gets attached here, that is Na plus will be attached here, and it will be, the rest will be same, CH2OH. This thing formed is called sodium salt of glucanic acid. But we have nothing to do with this product because this thing is colorless. So this is the oxidation of glucose. Now there will be a reduction of the CuOH twice. When it get reduced, it will form this product. It will form plus Cu2O. This is called cuprous oxide. And the oxidation state, as we can see, is here +1 oxidation state. So the Cu2 plus get reduced into Cu plus, and of course few molecules of H2O will be formed as a byproduct. Now let us see the principle that it will follow. So in principle we can write that Fehling's reagent gets reduced when heated with reducing sugars. Forming cuprous oxide Cu2O, which gives red PPT. So now to summarize this, we can write Cu2 plus of Fehling's reagent get reduced into Cu plus ion. This is our principle. So now the third test, that is Benedict's test, and the Benedict's reagent is actually also copper, but it is copper citrate 2 minus. And the one thing to be noted here also, Cu is in 2 plus oxidation state. The Benedict's and Fehling's are very much similar. Okay. Now the procedure is very simple. It is same as Fehling's test. A small amount of extract, added few drops of Benedict's reagent, and heated or boiled in water bath. So now it will also give the end product of red PPT, because the in product form will be same as the Fehling's test, that is cuprous oxide. Now for the reaction, let us take example of course we can take example of same glucose CHOH 4, then CH2OH plus Cu citrate 2 minus, when it will be heated, it will get oxidized. It is also for reducing sugar. That is another thing to be noted, for reducing sugars. So when this reaction takes place, it acts as a reducing agent and reduces copper, and itself get oxidized. When it is oxidized, it will form the carboxylic group CHOH 4 CH2OH, plus here there will be formation of Cu2O, that is cuprous oxide, and this cuprous oxide gives the red PPT. Okay, now if we talk about the principle, its principle is same as the Fehling's test, that the reagent get reduced having Cu2 plus get reduced to Cu plus of Cu2O, giving red PPT. Another thing to be noted, there is a result in many books that says blue coloration to red coloration, and this is actually brick red. So this is another thing to remember, brick red. So blue coloration is actually of citrate, copper citrate. It is actually blue, which then converts into red PPT, brick red PPT. So now we have all three reactions, biochemical tests for carbohydrate. The first one is the Molisch test. In the Molisch test, we have seen the reagent is the Molisch reagent, which is actually alpha naphthol with concentrated H2SO4 and the ethanol. So what will happen here? The concentrated H2SO4 dehydrate this hexose sugar, then condensation reaction occurs, and the formation of furfural will take place. In the Fehling test and Benedict's test, both tests are almost similar, only the reagents are different, and there is a difference of alkali medium. So in Fehling's test, we have seen that the Fehling's reagent having a Cu2 plus oxidation state gets reduced to Cu plus, forming by formation of Cu2O, which gives the red coloration. This is our red PPT, along with formation of sodium salt of gluconic acid and in alkali medium. Same in the Benedict test, we take the extract, we then add the reagent and heat, then on heating it will be seen that the reagent get reduced, Cu2 plus ions get reduced to Cu plus oxidation state, and this actually Cu2 is in a red colored PPT or brick red color. That is the little difference. Here it is red, here it is brick red. Okay, although they look almost same in reality. Okay, then thank you.